Okay, ladies and gentlemen, welcome back to Earth Science. Let's cover the second half of mineral classification. We've already covered 4 different characteristics: color, luster, streak, and cleavage. Let's discuss the Mohs scale of hardness and relative hardness and other properties. So today, let's start with the hardness scale. Mohs scale of hardness. Okay. This is an important piece to help you segregate different types of minerals based on their hardness. The scale is not about an absolute hardness, but rather a relative hardness of comparing the hardness of one mineral to another. So basically challenging them up against each other. So for example, talc and the mineral gypsum are similar in nature. They're both white in color, tend to leave white a streak. But talc is softer than gypsum, and the way you test this the way you test it is through the hardness. Talc is the softest mineral on the planet. It is a number 1. Okay, gypsum is number 2. But gypsum, if you put gypsum and talc against each other, gypsum can scratch talc, but talc cannot scratch gypsum. Does that make sense? The hardest mineral on the planet is a diamond. It has a relative hardness of a 10 according to the Mohs scale of hardness. This is an image of a uncut diamond or a raw diamond. Now, don't confuse hardness with the ability to break. It's really important. If you hit a diamond with a hammer, you probably can get it to shatter into multiple pieces. But if you hit copper with a hammer, it might not be as brittle as metallic minerals tend to leave, as metallic minerals tend to leave a dent and not shatter when being struck with an object. So even though diamonds are the hardest mineral, it can't take blunt force as copper could, for example. So the hardness scale is used to determine the mineral's ability to scratch another object. So here's the table right here. The Mohs scale of hardness. Talc is a 1, all the way through diamond, which is a 10. It goes talc, gypsum, calcite, etc., all the way up. And then here's some common objects that we'll compare in hardness. What we will use when we do our labs is our fingernail, a penny, and a glass plate. And then there's another one we'll put in between here at a 4.5 as an iron rod or a paper clip. A masonry bit is an 8.5 because the tip of it is a tungsten and a tungsten carbide bit, which is carbon and tungsten together, which hardens it enough to be able to cut up through topaz. Only these two here can cut anything above that. Hence why we have diamonds as a primary source for cutting hard rock. Okay? Make sure you understand this. We will use these common objects to help set up the precedence of what is stronger versus each other. Okay, so as geologists, you're not going to be carrying around, most likely, diamonds, right, to scratch minerals and etc. But you will carry some common items. Your fingernail, unless you decided to rip them off, hopefully not. That would hurt. Don't even think about that. Iron nail, you might catch a nail somewhere. Your blade, like your knife blade, is about the hardness of a glass plate, or glass can get as hard as up to a 7. These are some possible common items you can find or use. Okay? Now, for our labs, we're going to use some of these items to help identify the minerals. So, if your mineral can scratch glass, you know it must be harder than a 6. If a mineral cannot scratch your fingernail, then you know it must be softer than a 2.5. If a mineral can scratch your fingernail but not an iron nail, then the mineral must be between 2.5 and 4, which then at that point you could use copper as well. This is the process, or this is the thought process behind using the Mohs scale of hardness. Okay? The last step in identifying minerals is to understand some of their unique properties. Okay? The unique properties. Because some of these unique properties can easily identify some minerals, for example, the mineral sulfur smells like smells like and burns like sulfur. The same smell you would have when you strike a match. Halite tastes salty because it is salt, ladies and gentlemen. And below are some samples, for example, that you will look at. You have some double refraction, you have magnetite, so it's magnetic, fluorescent. It can effervesce, means it can have a chemical reaction with an acid, feels soapy, etc. And then here's a list underneath here that I'd recommend you going through. Translucent, fibrous, piezolytic, all definitions are written here. You can look at them afterwards. Opaque, conchoidal fractures, oolitic, iridescent colors, vitreous, transparent, striations, adamantine, variegated, rhombic, foliated, and isometric. Okay? You can also use what's called specific gravity. It's a fancy way of saying density of objects on Earth. You have already done a lab like this where you determine the specific gravity by dividing the rock's mass by its volume found in water. Metallic minerals tend to, just don't forget that, metallic minerals tend to be more dense, okay, than non-metallic, as a rule of thumb. Okay, so the activity that you're going to do is you're going to use a piece of glass, a fingernail, penny, and a paperclip to determine the hardness. And you're going to write it down on your continuing lab that you have already begun working on the last 2 days. And you're going to fill out the relative hardness of each one of those 9 minerals, and then indicate also the other properties that are found in the corresponding column, other properties from the ones that we have listed all up here. Okay. Now that you understand, after you finish this, now you understand what many of the mineral characteristics are. It's time to use all this gathered information, once completed, to identify the actual mineral. That's the last column we have left to finish in our lab. Scientists use what's called a dichotomous key. A dichotomous key, what does that mean? Dichotomous means to divide into. So you're splitting them up based on characteristics until it can funnel down to the name of the mineral. Scientists use these dichotomous keys in many areas of science to help identify objects like rocks and minerals, plants, animals. We use the dichotomous key in helping identify minerals and rocks in this upcoming lessons. So dichotomous keys, you'll use this for the, dichotomous keys use questions to help focus a direction in determining what type of mineral you choose, or that you have. So in this case, we're going to ask these types of questions. What type of luster does it have? And you identify it. And then you ask, how hard is the mineral? It starts to focus in more. Does the mineral have excellent pore and no cleavage? Now that you have eliminated a whole bunch of potentials, you look at the streak color. You look at the main color of the mineral. Then you look at unique properties. Finally, you have to determine if it's got a specific gravity. Once you do this, you should be able to identify your minerals using this dichotomous key. This is the link for the dichotomous key opened up here. You will use this key. Again, these are characteristics. 1, luster, hardness, cleavage, streak, mineral, unique properties, specific gravity, and then the name of the mineral. So you will ask yourself, is it metallic or non-metallic luster? If it was metallic, okay, now you only have to focus in on this yellow, or these 8 or 9 mineral names. Immediately reduces it. Then you got to identify with the hardness. Well, it's soft. Okay, now you have 3 left. Then you say it's got excellent cleavage. You have 2 left. Then you say it's a black in color for a streak. Bam, graphite. For example, you'll do that for this whole lab. This is what you use. Okay. Any questions? This is our lab to finish up chapter 2.3 and chapter 2.4, which is this right here. This is understanding mineral dichotomous key. This is the lab you will do in conjunction with finishing your mineral identification lab, which is what you've been working on the past 2 days and plus today. You will use this once you finish through other properties. You will not answer directly the name of your mineral. You will use this lab and I have already filled it all out for you except the mineral name. You will follow these characteristics on the dichotomous key and figure out how to use this key based on these already filled out characteristics, so you can easily understand and know how to use it. Once you finish this, then you go back to your mineral lab and complete it. Any questions? Thanks, guys. Let's get this started.